Welcome back to the 3-Minute AI Tip series for a practical AI for business. Let's move on with what we did from last episode, which was labeling 200 rows with targets. Now, say you build a model from that and you fit the model to the data and it comes back with a 99% training score. Do you celebrate? No, you don't. Not yet. And I'll show you why with real numbers from a real run. And 5 checks that are important with regards to any model that you build that's fit on custom data. None of which needs you to be a data scientist, by the way, if you're working with the right vendor. So you can follow the numbers, right? Here's the run I'm using. 15 years of Yahoo Finance data on the 100 S&P 100 stocks, plus the VIX, 292,000 rows. This is data from Kaggle. Realized volatility, momentum, RSI, volume. This is real market data. And the target is a forward 21-day. The question it answers is, over the next 21 days, does volatility go to calmer, stay similar, or get stormier? 3 balanced classes and 73,000 records held back that no model ever saw. That means that we took the Kaggle data and we split it into training data, prediction, and target. What the service did is provided a tournament that compared 12 models and find the best model from that tournament. Say 12 models, same data. And if you take a look at the random forest here, it shows 99%. It memorized the answer key. That's what random forest did. The winner scores actually 44 on training and 46 on the unseen data, and a lower headline. It is, and it's an honest model. Only the unseen number counts, not the training data. This is the second check that's required in a model. And this one will save you from being fooled by a vendor, by yourself, or anyone else. Always ask what random guessing would score. 3 balanced classes, random gets a 33% match. The model gets 46%. That's a real 39% edge in stock volatility. Now you'll look right. 88% sounds enormous, but random already gets 78% on that measure. Same model, same run. One number is impressive, the other is mostly baseline. This is the third check that's required in a model. 46% is an average, and the average hides everything. You break it apart. This model gets the middle class right 55.6% of the time, but the other two sit around 40. Same model, same very different reliability with regards to the predictions on a specific class. So you use it where it's strong, and you don't bet the business on the class it's worst at. This is important to understand in building a model and evaluating a model. Here's the fourth check, and almost nobody does this. Don't just count what it got right, count what it said. This model predicts the middle and a safe class about 40% more often than that class actually occurs. That's a conservative bias. Not automatically wrong, but you need to know it's there because a model that overcalls the safe answer looks accurate while quietly missing the events you care about. This is an important part of evaluating the model. Here's the fifth check. Not all errors cost the same. Being one class out is a rounding error. Being 2 classes out is the one that hurts. Random guessing lands 2 classes out 22% of the time. This model does it 12%. That's a 46% cut in the misses that actually blow you up. Average miss, not 0.66 out of a possible 2. It gets magnitude wrong, but it rarely gets the direction wrong. So there's your scorecard for a model based on a test of stock liability. Here's your scorecard. Unseen score, random baseline, per class, predicted versus actual, and the cost of being wrong. 5 questions, and they work on your own model or on any vendor's model, not just ours. And full disclosure, every number I just showed you came off this one screen on our own platform. Each match within one class, average miss per class breakdown. This is an actual screenshot. All 5 checks on one page automatically. That's our AI model manager. 2,292,000 rows, 12 models, 0 code. So here's the whole episode in one line. A measured edge beats an impressive number every single time. 99% with no baseline and no holdout tells you nothing. That was the model that was wrong, but implied that it was 99% accurate. 46% against a random 33% on 73,000 rows it had never seen tells you exactly what you've got. No model guarantees an outcome. Validation tells you how big your edge is and whether it's real at all. On to the next tip. Cheers.